My name is Roberto Barbera. I'm working at the University of Catania, and I basically do my research at the Italian National Institute of Nuclear Physics since my graduation. Since 10 years I work on grid computing and in different projects, and my main aim is to see how to develop so-called training infrastructures and easy tools to access these grids. And this is actually the main aim of my presentation. When we prepared the program, Margaret asked me to give a tutorial. But tutorial means too technical thing, and I'm in the uncomfortable situation to be between you and the cocktail. So I thought about, and in the end I think that what I would like to do is to leave you a message that you can bring home. And bringing this home, you can think that if you want to join the infrastructure, if you want to be part of this large infrastructure, you do not have to start from scratch. And I want to provide you some end points, some starting points actually, not end points, from where you can get information, get trained, get support, and then try to get things done. So I will try to describe the path to the adoption of the infrastructure paradigm. Then I'll show you some example of applications, and I've chosen a particular set of applications. I'll explain you why later. And then I'll explain you briefly the EPIC project that Bruce already mentioned before, and the opportunities that the EPIC project can provide to Sub-Saharan Africa. And then I'll draw some summary and conclusions. So this is the global network as we understand it now. I mean, with the onset of the Africa Connect project. And as Federico said before, on top of this network infrastructure, people are trying to build the global grid with project funded by the European Commission, by the US funding agencies, by Japan and other sources. And the net result of the two things is this one. So basically, you have the world's largest distributed computing, general purpose computer for scientific research, 340 sites, almost 60 countries, hundreds of thousands of CPU cores, hundreds of millions of petabytes of data, millions of jobs, 20,000 users across more than 200 virtual organizations. So the question is, how can you join all this and profit of all this? So I'm trying to concentrate my presentation in trying to answer your question. So, chain, before talking about chain, the path to the uptake of the infrastructure paradigm as the path to uptake any other modern technology starts from awareness, information, training, user support, and then of course funding. The way you can get funded and the way you can get organized have been explained by my colleagues before, so I'm trying to concentrate on this virtuous cycle. I will start with awareness, information, training, and support. Actually, the first step we are all doing here because we are in the same room and you are listening to our presentation and we are sharing the information with you. Then I'll try to be more concrete on this part. So, chain, this has been mentioned before, has built what we call the knowledge base, is the largest e-infrastructure knowledge base, and we have information for about half of the countries in the world, Europe and outside Europe. And if you go to this page, you have this nice map, you can click on one of the continents, and then you can try to drill down. You can click on Africa, and not surprisingly, you have lots of information, because there is a lot of information. So for each country where you have a pin, you have information. And the information we provide are the regional network, the National Research Network, the National Grid Initiative, the Certification Authority, the Identity Federations, the Regional Operation Centers, the grid sites, and the grid applications. So for each country, you have at least one of these items. And then having an item means that you have a link. And from the link, you can get a website, and then you can get the contact. You can talk to someone. You have an email address at the end. So you are not alone. You can get information on what's done by the different countries, not only in Africa, but also in the other continents. And we try to get this information automatically updated from external sources, because we want to provide visitors to this knowledge base with fresh information and updated information. So we also have Europe, but of course we do not replicate the information that is already existing in the EGI databases. So we simply link the EGI relevant pages, of course, so you can have the information from the continents outside Europe, and you have only the links to the relevant pages for Europe. So if you want to start with NRENs, and then many NRENs have been already established or are being established in Africa, but the most important starting point, of course, is the Terrena website and the Terrena cookbooks and white papers. So if you plan to start an NREN, or if you want to have more information on the services which are operated and run by the NREN, this is the starting point. If you want to start with the NGI, Onion already told us how you can do this. Some general recipes. These are more concrete documents. This comes from the chain wiki. It is a list of documents from different sources, from EGI, from Sigrid, from other countries, with technical documents, policy documents that you are free to reuse if you want to start the NGI. So you do not have to reinvent the wheel. You do not start to do. You only have to concentrate on one thing: cooperation among your country, among the organizations of your country. The technical and policy documents, there's a lot of stuff already out there that you can reuse. C8s. The problem is that every transaction on a grid infrastructure has to be signed by a digital certificate. So you can go around this problem, and I will show you on Friday the way to do this, but you cannot eliminate, you cannot avoid having certificates. Every transaction, server to server, human being to server, has to be signed by a certificate. So you must have an authority that can issue certificates. So if you want to start with certification authorities, the starting point is UGrid PMA, which is one of the 4 PMAs in the world that gather all the certification authorities, all the countries operating a certification authority. And in almost all the cases, certification authorities are operated by the NREN. So that's once you have a certification authority, you can use certificate not only for grid, but also for many other purposes. So this is very important. This is the first step, unavoidable step that you have to take. So if you want to start with technical things, the certification authority is the first one that you have to tackle. Second one is identity federations. I like very much the definition of the identity federation that I copied down. Identity federations are the ensemble of agreements, standards, technologies that make identity and entitlement portable across autonomous domains. So the concept of the scientist that goes around the world and he can access the infrastructure from wherever he goes. So still keeping the same credentials that are provided by the organization he or she belongs to. Having an authentication and authorization infrastructure allows you to have one single pair of credentials to access several services. I'll show you on Friday how you can use this to access the grid, but building an identity federation, having different identity providers and service providers allows you to share different kinds of resources. So people from one university can log to an e-learning system, but they can log to other services from other universities. So it's a way to identify someone and let him access different services. The grid can become simply one of the services. e-infrastructure can become one of the services. So you can mesh e-infrastructures, digital libraries, content libraries, and all these kind of things that are part of the scientific operations that each researcher does day by day. So REFED is a Terrain task force intended for identity federations, and you have white papers, you have technical papers, and you have examples to build identity federations, and also administrative papers to create the agreement and the policies for the identification of the people. Coming back to the knowledge base, the chain knowledge base has three views. The country view, I told already, I showed you already. The second view is the site view. Each yellow dot here is a grid site. Of course, we print grid site outside Europe because we do not, EGI has its own monitoring system. These are the grid site outside the EGI, the outside Europe, and for each of the sites, you can click and you can get information on the computing resources, who is operating the sites, because we directly get information from the operational database containing site information. So if you wanna switch on one of these green dots here, somewhere here, this is the first step. So Africa and Arabia Rock, actually, you have several services, and you have also the site installation guides and links to site installation guides. So I'm not saying that you can do this by yourself starting from scratch, but you have already documents and you can be supported. In fact, one of the services of the Africa and Arabia Rock is a two-level user support. We started doing this since more than 1 year, and so we have two levels of support. One level is the country level, and the second level is the level of experts. So everybody, an operator, a site manager on duty, or a simple user can open a ticket. The ticket can be redirected to the expert of the country. If it cannot be taken by the expert of the country, it's escalated to the second level, and then you can get support. And here you have all the kind of supporting areas and the ticket statuses. So you, being part of the Africa Rock, you can become member of this user support, partner of this user support, and get supported from the very beginning to the end, and also during the operation of your sites. Another database that we are building inside Chain is the application database. So basically it's a list of applications. We have 128 applications starting from all the continents outside Europe, and then we have links, of course, with the corresponding database for EGI, and you have information on the applications, and for each application you have lots of information, technical information, who's working on the application, references, papers, proceedings, and for some of them, and we are increasing this number, and we will be increasing this number in the next weeks, you can click and you are automatically redirected from a web page from where you can run your applications. So the big advantage is you do not have to install anything. You go there, you register with the credentials you have of the identity provider you have, and then you can run the application. And if you want us to bring application, to have more applications that are runnable from within the website, I will explain you on Friday how this can be done and how your communities can profit through this. So the main requirement is nothing outside the web browser. The grid should be as easy as browsing the web. So now let me come to the applications. There are many applications that are shown when people talk about grids and communities and BRCs. There are many figures and applications. I wanted to make some examples because I want to bridge grid computing and high-performance computing that's quite surprisingly is taking non-parallel directions in Europe and in other countries. If a middleware is just a protocol to
bring a job from one side to the other. When the job lands on a site, it depends on the site. If you have just a cluster of machines with a gigabit Ethernet, then you can do high throughput computing. But if your site is very well equipped with InfiniBand or low latency networks, you do high performance computing. High performance computing or grid computing or high throughput computing depends on the hardware that you have on the sites. It doesn't depend on the infrastructure. So you can mix, again, you can mesh high throughput computing and grid computing depending on your applications and depending on your needs. And there is no reasons why the two communities are different, and there is no need for the ICT operators at the different universities to support different things. So, of course, the main customer, I cannot avoid talking about energy physics. Energy physics is the main customer of the infrastructures in the world, especially the 4 experiments at the Large Hadron Collider at CERN, and you can understand why from this figure. So this is one of the experiments. The idea is to replicate the first microseconds after the Big Bang, doing a little bang, smashing lead ions one on top of the other and producing lots of particles, creating a density of energy which was similar to what was in the first tens of microseconds after the Big Bang. Of course, when you smash 400 nucleons, lead on lead, one on top of the other, this fantastic energy, you produce tens of thousands of particles. If you want to detect all of them, you have to have hundreds of millions of sensors, and then you produce a real lot of data, petabytes of data, hundreds of times the content of the web, at least the visible content of the web. So energy physics is, for energy physics, the infrastructures is not an option, it's a must. But there are other communities that can profit along, that can profit also. This is a different thing. This comes from astrophysics, and this is high performance computing. So Flash is a de facto standard in astronomy and cosmology, is a highly parallel code, and we run this on a grid infrastructures where the sites were equipped with low latency networks. And you see, we use hundreds of cores even for 1 or 2 weeks. I mean, these are CPU years of calculation, and you cannot do this on a normal cluster. This, you need a grid infrastructure to run this. Oh, okay. That's another thing. These are coronal mass ejections from the sun, and this is a full 3D simulation. These are 2 CPU years done in less than a week. So if you want to tackle this kind of problems, or if you want to be part of communities addressing these issues, the scientific issues, e-infrastructures, again, is not an option, it's a must. But grid is not only for calculation. Grid is only for data mining. Grid can be thought about a huge data warehouse where you do the mining. And this is an application. These stand for visualization, and IVO is the International Virtual Observatory. They aim at building a virtual sky. And okay, I don't have to show the video, but I want to go fast on the other applications. So, other applications, Monte Carlo simulations from radiogenic machines for the health, for the determination of the treatment plans. This for particles and also for photons. So simulations. This is a trivially parallel problem, Monte Carlo problem. You can split on thousands of computers, and then you can reduce thousands of times the time of calculation. Digital archives for earth science, with a normal web interface and also with a mobile interface. Digital archives for cultural heritage, from the digitization to extraction, to download of the resources to your laptop or even to your smartphone. This is commercial software. This is Fluid. This is a very known software in the computing fluid dynamics, And these are two calculations. So you can manage on the grid also not only open source software, but also commercial software. There are no barriers. So if you have licenses, and we have a management of license on a distributed environment, you can run this kind of simulation. This was an environmental problem, and this is a problem of building a refrigerator. This, maybe you can just spot is here, a refrigerator that you can find in your supermarkets. Applications from Latin America. I will talk on Friday about applications from other parts of the world. Earth simulators, fire growth simulators, NMR tomography, water control. Applications coming from, and some of them are parallel, some of them are sequential. All of them you can run on a grid infrastructure. And some of them you will be running very soon from within a web browser. You don't need to install anything. So, E-infrastructures are fundamental to connect the two vertices of the triangle of knowledge, research and development and innovation. But you also need education and training, because you need to shape the e-researchers of tomorrow. So you need training infrastructures again and training programs. And this is where the EPIC project comes in. EPIC is a Marie Curie action, it lasts for 4 years, is a worldwide project with 23 partners, 80 countries. And what we basically do, these are the partners, we want to reinforce the impact of infrastructures and broaden the engagement in science activities. How? Spreading the knowledge with the grid schools, easing the access of training people to the infrastructures existing in the area, and fostering collaborations. So this is done by a secondment program. And we run this in two phases. In the first phases, we invite people from non-European countries to Europe, to several institutions in Europe, and they run research programs. And in the second phase, we go to the non-European countries and we run grid schools. We already funded, we got 75 requests and we already funded 63 research programs. This is the 90 secondments done so far, the EPIC events, and these are the kind of events. First kind of events, grid site installation. So we have schools dedicated to install a grid site. And we already did several things. Second event, grid school for application porting. So we basically open a call for applications. We selected applications, we invite people to the school, and we gridify these applications. We plan to do this 24 times and 8 times in Africa. And the next school will start next week in Jordan. So what we want to do by this, we want to implement another virtual cycle from dissemination, workshops like this one, training events, schools, gridify applications, deploy the applications and infrastructure, keep a demonstrative version, and demonstrate in further dissemination events. So this is the call for application, and we babysit the applications from the very beginning to the production stage. We accept the applications and then we make it evolve to the different statuses that we identified. As Prof said, we have a database which is part of the chain knowledge base, of course, with all the applications, and from each application you have information on who's working with, you have videos, you have demonstrations, you have also test suites, and for some of them you have also web interface we are working on. So, concerning EPIC, is doing the training for many projects. It's a kind of training grid training platform. It has been one of the success stories of Euro-Africa ICT and has been mentioned as a sample to follow in the last conference on sharing knowledge. All this success convinced the Commission to authorize school and secondments in countries, or from countries which are not part of the original consortium. And next schools are being organized in Colombia and Ecuador, and we have requests from other continents. So one opportunity for you is, if you are interested, we could try to organize a nice follow-up of the first event that we ran in Malawi 4 years ago, but much more extended and now much more focused on scientific communities. So this is my last slide. Let me summarize. So infrastructures are changing the way we do scientific computing in many aspects, in many domains, not only in scientific computing but also in other sciences. They allow to tackle unprecedented challenging multidisciplinary problems. I try to give you a flavor of this, and are considered key enablers of the progress of a country. So it's very important that the region could join the community building an infrastructure, and this can be done step by step. So along with the NREN, the regional network, Ubuntunet, Ubuntunet Alliance, WACREN, I think that if you really want to take off, you need to tackle the problem of certification authorities and identity federations. Otherwise, you will not speak Greek, and you have to organize local trainings. You need to build the know-how here. You need to, there should be a know-how, a competent group of people, a team of people, a task force that can get applications and deploy applications on the grid on demand. So you can also identify brilliant people, and we are very welcome to host them in the European organizations working within EPIC to run research program of your interest or in a mutual interest, starting a collaboration. And of course, Chain and EPIC are willing to help and support, and I'll try to give you more information on Friday, how these things can be, how the supporting of applications, how this interface, how this running can be done in an easy way. So thank you very much.